Hello, my name is Jeon, PhD and CEO of IntFlow, which is located in Gwangju, South Korea. Well, today's topic of my research is named Lightweight Unit-based Monaural speech source separation for edge computing device. Here's the content, as you can see. Well, I'm going to start with a definition of monaural source separation in my research. First, let's assume the speech source is interfered by noise such as environmental noise in construction site or keystroke by keyboard typing or the airplane noise, etc. And those kind of interfere with the speech source is mixed, and these kind of mixed signal are normally recorded to microphone. That's a quite usual scenario, and well, there are many kind of denoising algorithm, but in this scenario, we stick to the single channel case. That's why I named the monaural speech source separation. Obviously, the goal is to separate speech source from mixture signal within single channel microphone. Okay, there are some algorithm to try to tackle this problem, especially as another field does. The monaural source separation also aided by deep learning techniques such as simple multi-layer neural net, deep recurrent neural net, or wavenet, etc. And they every kind of algorithms improved the speech separation performance in their own way. However, in our research group, recent research showed that UNet structure, which has been widely used for medical image segmentation, it has been implemented speech separation successfully. And it confirmed excellent performance even in very harsh conditions, such as wind noise or drone noise. And I doubt that you can see the I'm sorry. I have some. I prepared some the sound demo, but I doubt you can hear as me as well because it's a very small speaker. But let's listen closely, please. Can you hear from? No, well, I'm unfortunate that there is no speaker system in here. Well. Can you hear the differences? Another sample. Yeah, it's a drone noise with the girl screaming, and only you can hear. Only the girl scream can be heard. That's power of UNet. Yeah, it works quite well actually. But however, that's not my contribution in this research. Well, there is a drawback in unit-based model because unit generally comprise more than 10 convolutional layers, and the number of network parameters range from 10 million to 100 million. It's quite burden to most mobile devices, such as cell phone. And this graph shows that as the number of parameters grows, it obviously increase the flops complexity, and the error goes down because they conduct more computation. It's quite obvious situation. Well, so to tackle this problem, we propose a high-quality sound source separation method that can run in real time on edge computing device without the help of server or network using lightweight unit model, which is going to propose. The proposed model significantly reduced the number of parameters required for actual learning by applying dimensionality reduction module between 2D convolution operation that is going to propose in a few slides after. Well, here's some technical details. It's a quite simple equation to define the monaural source separation again. Let's consider a microphone whose input is mixture of speech and noise, where speech X and interferer D denote in I and K denote the K spectral component of speech and noise at the I frame. That means that we conduct an algorithm in the spectrogram domain. And in most cases, we discard the phase information, and only the magnitude of the spectrogram are used to the separate the source in unit, because the unit are made for the image, which is physically equivalent to the magnitude of a spectrogram.